Hello, Year 11, and welcome to this, our fourth video for our fourth topic. We are collecting data generally, and today we are looking at sampling techniques. Not, the way that we might record some modern music. No, not that kind of sampling techniques, not that kind of sampling. We are looking at how we collect our data, right? How we get that data. So, first of all, two options. One, I've got a population. There are some, elements within my population, whether they're people or products or something. But if I collect information from every person in that population, then I have a census. It's a great history of censuses. The Domesday Book, compiled by William the Conqueror after the Battle of Hastings in 1066 in England. Right? The census the Romans were doing when Jesus was born. That's why they're on the road. That's why he was born in a manger, because, they weren't at home. Right? Censuses go back a long time, collect information from everybody. The alternative to this is a sample, right? I skip some people, only do some of them. Right? Why would I do that? Well, a census you would tend to think is going to be fairly accurate, right? Because you haven't missed anything. You've asked every single person there. You've got information from them. You're not making any assumptions. There's no bias within that. So that's a good thing. Flip side, census, expensive, slow. Because it's slow, perhaps the data set has changed during the time it's taking you to collect it, right? So it can, in fact, introduce some inaccuracy that way, right? But more difficult generally, a census. A sample, typically faster. There are other times we definitely want to do a sample rather than a census, right? I might be working in a factory manufacturing light bulbs, and I want to see how long it will burn for before it blows up, right? Before it burns out, right? And I do that by testing it to failure, right? I plug it in, I jack up the power or something, and I wait for it to burn out. If I did that to every light bulb, well, I would have a really accurate idea of how long my light bulbs last. I would also have no light bulbs. Yep, because I'd have broken them all. So sometimes it's really important. Sometimes it's kind of pointless conducting a census that I definitely want to sample. Now, what type of samples are there? How can we collect a nice, representative, unbiased sample? Right? How can I do that? Well, let's talk about some things that are not in the notes here first. Some ways of making sure we've got a good sample is that it's a large sample. Typically, the bigger the sample, the more reliable it is. A large sample is usually a better thing. Also, we want to make sure that our sample is representative, okay? That it is unbiased, that it doesn't select people for my sample based on any particular characteristic, right? It really needs to be random, okay? Without bias, it needs to represent the population. Now, how could we collect a random sample? Well, I could put names into a hat and draw one out at random. I could assign a number to everything and use a random number generator on a computer or a laptop, or a calculator or something, to generate random numbers and match them up, right? Something like that. I could give everyone a number and, roll a dice or something. Whatever number turns up, well, I match it to that. So, random sample is done that way. A systematic sample, right? This might be like the light bulbs that I'm going to check to see how long they last before they fail. So I choose the first one at random. Right, choose the first one at random, and then I say, well, I want to test 1 in 50, so I'll choose every 50th light bulb after that. Right, this is good for a population with a poorly defined size. Right, if I'm working in a factory where I'm making light bulbs, how many light bulbs are there? Well, I'm making new ones all the time. I can't really say, right? But I'm just going to test every 50th one or 500th light bulb or something like that. Choose the first one at random, right? And choose them at a fixed interval afterwards. That's a systematic sample. A stratified sample, earth and environmental scientists, you might be able to connect this to the idea of strata with rocks, right? Strata are layers. A stratified sample is where I go to additional efforts to make sure that some subgroup within the population is fairly represented, or that each one is fairly represented. So let's say, for example, let's say there are 250 people in Year 11 and 150 people in Year 12. And I want to collect a sample of 100 students that represents the interests of Year 11 and Year 12. So, how many from each group do I need? Well, there's 250 11s and 150 12s, mean that there are 400 people altogether. Now, out of that 400, 250 are Year 11. So what percent is that? Right, well, 250 divided by 4 is going to give me 125, 62 and a half. Oh, so I need 62 and a half Year 11s. Let's say 63 Year 11s and 37 Year 12s, right? And that would be how we get a stratified sample. Right? In layers, we work out how that group is represented within the population, and we represent the same group within the sample the same way. And finally, our self-selected sample, right? This is an example of a bad sample. So that is where people might choose to participate, right? If you do an online poll, you see these things on dodgy TV shows or something, where they say, 95% of respondents think that we should ban people who don't like Australia Day. Something, I don't know. Where you have people phoning in to vote or something, when you choose whether or not you're going to participate, because it's very likely to introduce some sort of bias. That those who choose to participate are likely to hold a different or have different characteristics to those people who don't choose to participate, and so you end up with a biased sample, and it's unreliable for that reason. Now, we want to wrap this up fairly quickly, but here's another example. I want a sample of 60 students from 250 11s and 200 Year 12s. Wow, this is a lot like the example I went through. Right, we'll write it up nonetheless. How many students from each year should be sampled? Well, altogether I have 250 plus 200 equals 450. Therefore, for Year 11, I want this fraction. I want 250 out of 400. I want that fraction of my 60 to be Year 11s. Rightio, 250 over 400. Oh, geez, I'm going to need a calculator. Hang on, this was prepared earlier. 250, I'm going to use divided by for my fraction, divided by 400. Right, so 0.625 or 62.5% of my group is Year 11. If I multiply that by 60, right, 37.5, we're going to round that up to 38. So I want 38 Year 11s. And look, I could say 200 over 400, which 200 over, whoops, hang on. Sorry about that, people. It's over 450, not 400. That means I need, 33.3. We're going to have to round that down to 33 Year 11s. Now, you might want to do a check by doing 200 over 250, 200 over 450 times 60, and you should get an answer of 27 there. Right, but I'm pretty confident here, and we want 27, just so it adds up to 60, 27 Year 12s. Okay, that's how we do a stratified sample. Other than that, the rest of these, there's not a lot of calculation involved. Rightio, it's mostly stratified sample where you get a question that requires you to do some calculations. The rest of them might talk about, they might ask you to explain the benefits or deficiencies of a certain type of sampling technique. Righto, that's how these questions generally go. Okay, I hope you enjoyed. See you in class.